Hi, welcome back to my channel and welcome to the Infinite Limits video part 2. So we will be continuing what we have started on the infinite limits last time. So this time we will be providing additional theorems that we will be using in order for us to solve different kinds of functions of different types. So before I'll start with for today's video, I would like to say thank you again for all of those who supported me, and for those who are new to my channel, please don't forget to subscribe so that you'll be updated on a lot of videos that I'll be uploading soon. And just so you know, I am currently doing these infinite limits. This is for grade 11 of senior high school and for those who are currently taking calculus in college. Okay, so we will have now the first theorem here. And this theorem is good for the function of the format f of x plus g of x. Okay, so it says here that if the first limit, okay, according to number 1, if the limit of the first function is infinity, so this is positive infinity, the limit of the second function is any real constant number, c. So by the way, this is real number. This is real number. Okay. So if this first function has a limit of infinity, and then the second function has a limit of any real constant number, then according to number 1, the result is positive infinity if the first function has a limit positive infinity. For the second one, it says that if the limit of the first function is negative infinity, then the entire thing is negative infinity. That's it. Okay, so let's consider an example here. So, assuming we're interested to solve for negative 3 over 3 minus x plus x over 2 plus x. That's it. And as x approaches 2, 3 from the left. Now, let's double check first which of these two is f of x, which of these two is g of x. This one here I'm referring, because of course the sum of two functions is actually commutative. So I'll try to see if it works here. The limit of negative 3 over 3 minus x as x approaches 3 from the left. So if I double check on the above, I mean the numerator, the limit is the limit of the numerator, so that's negative 3 as x approaches 3 from the left is actually negative 3. So that's constant. And if I take the limit of 3 minus x as x approaches 3 from the left, this is 0. So by the previous video, I mean the previous theorem of the previous video we have, the part 1 I mean, this qualifies for the 4 classifications of theorems. So you might want to check on that. I'll give you the thumbnail here. And these results to negative infinity. So if you have question, please comment down there so that I would know and we can discuss that. So hence, this is the f of x here. Hence, the limit here is negative infinity. But we would have to check first the second if this is a constant real number. Because we need to make sure that if one has a limit negative infinity, one has to be a limit of a constant number. Okay, so I'll double check. The limit of x over 2 plus x as x approaches 3 from the left, this is 3 over 5. So this is according to the theorem on the video for the basic theorems, and here's the thumbnail. You might want to check on that. Why did I get 3 over 5? Okay, so therefore this is our c here. So this is our c, which is 3 over 5. And so, according to theorem number 2, this is equivalent to negative infinity. That's it. Okay, so let's consider an example here. Let's say we're interested to find the limit of 5x over 1 minus x minus 4 over 3x as x approaches 1. Okay, so let's double check. So the limit of 5x over 1 minus x as x approaches 1. So let's try to check the numerator first. That's limit of 5x as x approaches 1. That's technically 5. Okay. And then the limit of 1 minus x as x approaches 1 is 0. So therefore, it qualifies on the previous theorem on the first part of the video. I mean, on the first part of this topic. So technically, this is 0, but where does it approach to? Okay, I'll just assume this as 1 from the right. Okay, so where does it approach to? Here. This approaches from the positive value, so this is positive infinity. So you might want to check on how did I get here. Please check the first the part 1 of this video. Okay, and so this is positive infinity, but we will double check first if the limit here is a constant real number. So let's try to check the limit of 4 over 3x as x approaches 1 from the right. So this is 4 over 3. So this is constant. And so according to theorem number 1, this is equivalent to positive infinity. That's it. Okay, so we have now the last theorem for this discussion of the topic. So it says here, these theorems focus on the multiplication of the function. So the first theorem that we have on this video is when we have addition of functions. In this case, we focus on the format for a function f of x times g of x. Okay, so first theorem says here that if one of the function, let's say the f of x, is positive infinity, and then the second one is any constant number, but it's not supposed to be 0, so any constant non-zero real number, so let's take note of that. Then the result, the limit of the product is positive when the constant, the limit of the second, is positive. If it's negative infinity, then the limit of the second function should be negative. And then in the event that the limit of the first function is negative infinity, then it's negative infinity entirely if the limit of the second one is positive. And entirely it's positive if the limit of the second one is negative. Now, you might wonder why I emphasize the word, the statement here, the phrase rather, that C should be non-zero real number. Simply because if you take the limit of this and it's 0, entirely that's 0. So we are trying to avoid that. Okay, so let's consider an example here. So let's say we want to solve the limit of negative x over x minus 2 multiplied by 1 minus x over x plus 3 as x approaches 2 from the left. So let's double check first the limit of negative x over x plus minus 2 as x approaches 2 from the left. So let's double check the numerator. The limit of negative x as x approaches 2 from the left, this is negative 2. And the denominator, the limit here is 0. So that means it qualifies on the theorem from the previous video. But to where does it approach to? This is on the negative values of 2 to approach to 0. So that means this is approach to negative values, but the numerator is negative. So entirely this is positive. However, let us double check here. What's the limit of 1 minus x over x plus 3 as x approaches 2 from the left? So this is negative 1 over 5. So this c is negative. So according to Mm, Theorem number one, when the first is positive infinity but the C is negative, so the result is negative infinity. Okay, so let's consider another example here. Let's solve for the limit of 7 over x cubed times 4x minus 10 all over x plus 5 as x approaches 0 from the left. So let's double check first the first function. The limit of 7 over x cubed as x approaches 0 from the left. So this is constant, so that's 7. But the denominator here approaches 0. So that means we qualify on the first theorem from the previous video. And technically, these approaches on the negative values of on the negative values 4x that approaches 0. So meaning to say, this limit is negative infinity. And if we take the limit of 4x minus 10 over x plus 5, as x approaches 0 from the left, so technically this is negative 10 over 5 or negative 2. So this means to say that this is C here is negative, and this f here of x has a limit negative infinity. So according to theorem number 2, the result would be positive infinity. Okay, so let's try additional example here. We are going to solve the limit of 2 over 3x minus 1 cube times x minus 4 over 3 all over x as x approaches 1/3 from the left. So let's double check. The limit here of 2 over 3x minus 1 cube as x approaches 1/3 from the left. So this is technically a constant 2 for the numerator, and for the denominator it is at 0. But to where does it approach to? This is from the negative values of 1/3. I mean the negative values of x. So that means this is negative infinity. But if we take the limit of x minus 4 over 3 all over x as x approaches 0 from the, I'm sorry, 1/3 rather, from the left, this is 1/3 minus 4 over 3, and that's technically 1/3. Okay, so technically this is C. This is the real number. We don't care if this is, what value is this, but we are sure this is a negative value. So therefore the C here is negative. So negative, negative, so the result is positive. So that's all for now. Thank you so much for watching. So if you think I lack so much of examples, like you need more examples, please let me know. You can comment down on my videos so that I can respond that quickly as I could. And if you have any questions or clarification, please comment down there so that I would know as well. If you would like to request any topic that you would like me to discuss on your online classes, please let me know as well. So thank you for listening, guys, and don't forget to check and subscribe to my channel if you haven't subscribed yet. And for those who have been here, thank you again. Thank you so much for your time and support. And once again, have a great day to you. Bye.